So this one, constant rate, constant velocity or speed, slowing down. Speeding up. Questions to hear before I make it seem more difficult?
So, for that sentence, would you say object is speeding up, well, object is traveling, but object is traveling in the negative direction with increasing speed?
This one right here? Yes, that works.
Okay, cool.
So both the upper one, so that one, and then the one on the left, that's down, sorry, like the horizontal line.
Oh.
So, yeah, those two are both constant, so how are they different then?
All right, they're both, when you say constant, again, we got several things working here.
Right.
They both have constant velocity.
Okay.
Because this slope is not zero, zero slope is like this. Because the slope is not zero, this one's moving. That one's not moving. So that's the big difference between those two. That no matter what time it is, the position is still the same.
Okay.
Is that sufficient?
Yes.
Okay, was there a hand over here? All right. All right, so let's see, we got three basic graphs there. So we had one like this, one like this, one like that, one like that. Basically the same order. All right, so those are basically the six that we just dealt with. Let's now make it velocity first time. And just for point of communication, we'll just call this A, B, C, D, E, and F. In which of these cases is it's a one-dimensional problem. In which of these cases is the object traveling in the negative direction? C and F. Why?
Because it's pulling down in the negative direction.
Lydia?
D and F?
C and F?
D.
D and F. All right, so
I didn't mean.
you went with those two, and Lydia, you're with these two. Is that, did you want to change your mind?
Yeah, I didn't mean to say C.
Okay, just F?
Yeah.
Okay, so you're going just F, Tana, and Lydia's going for these two.
I said D, E, and F,
And you're going for all three?
because that's what's going to be.
Yeah, that's position first time.
Oh.
What's the sign of velocity if you're going in the negative direction? Yes. If you're looking at a graph, how do you know if something's negative?
When it goes past the x-axis.
So, I'm gonna cringe as if I'm on that one.
Okay.
Say it again, except do it, say it right.
When the slope of, I don't know what I'm saying. When the line goes past the x-axis.
My problem was the term x-axis.
Okay, sorry.
In this case right here, what's the axis?
Time.
Yeah, time axis. I would have also accepted horizontal. If you're saying x-axis is always like that, and then y-axis, do air quotes if you're gonna do that. Because that sort of, it's part of the brainwashing of the math people. Let's break free of the brainwashing from math. And subject yourselves to the brainwashing of physics. So in which of these is it below that horizontal axis? Yeah, none of them are going in the negative direction because we don't drop below the axis. So you're moving in the positive direction the entire time. Now the question is, what's changing? In this case right here, what can you tell me about your speed? Okay, it is positive. That's true for all of them.
It's constant. It's increasing?
Yes. Because it's velocity. As time goes on, I'm getting a higher and higher number here. My velocity is increasing, so I'm getting faster. What about here?
It's slowly increasing.
I heard that I would give part credit for that one. All right.
Increasing?
Pardon?
Increasing?
Okay, yes. How is it increasing? And Luis, I see the hand gesture. What, you want to put some words with that?
I don't know how to say it. It's basically going up into a positive direction.
Well, it's going in a positive direction the entire time. It's above the horizontal axis the entire time.
The velocity is increasing over time?
Yes, that's true for
It's starting out
all of
slower?
those. Say it again?
Starting out slower and then speeding up?
That's true for all of those. I think I went too far on that one. Somebody said, I heard someone say, it's speeding up slowly. And I said I'd give partial credit for that.
Accelerating?
Okay, accelerating.
I know that that's not the way you want us to use it. Okay,
Would it be in a constant speed?
Say it again?
Would it be increasing in a constant speed?
Oh, if you want to say go into what, I think what you meant was increasing at a constant rate. Or not necessarily, it's not increasing at, the speed does not increase at a constant speed. That seems contradictory, where you're saying constant speed, but it's increasing.
So, I said it's slowly speeding up. Why would it be partial credit, or what would I add to get?
Why do you say it's slowly speeding up?
Because it kind of starts off horizontal towards the origin, and that's closer to not moving like you said, which makes it like zero, like flat. So, like when it starts moving, it kind of, it's not extremely steep, but it is, I don't know, getting to it. So.
And then at the end?
At the end, it's better, like it, I don't know, it's better than being.
You said it's better?
And that's
I'm
how
not quite sure what judgment call on that one. No need to apologize. All right, so the change, it is almost horizontal to start with. The velocity is low because we're near the horizontal axis. Same is true for all three of those. But the slope is also small, so the change is not much to begin with. But what happens to the slope as we go?
It's
It's
steeper.
steeper.
Increases, get steeper, both, either. So, Lydia?
doesn't it eventually just hit a constant velocity since it doesn't?
The way this is drawn, it starts out slow. It then increases slowly, but as it goes, the rate at which it's increasing speed gets faster, larger and larger. So it's getting faster the entire time, just like all three of those. But the rate at which it's getting faster increases as you go. So by the time you get here you might be changing at, say, 1 meter per second per second. Here it might be 10 meters per second per second. You have your foot on the gas pedal, you're sort of cruising along, and then you slowly push your foot on the gas pedal more and more as you go. There was, Kimberly?
So it starts off slow and then it goes fast?
Starts out slow, goes fast, but also the acceleration increases as you go. So that's why it was partial credit, because you just did it. It changes slowly, which was true at the beginning, but then it's not changing slowly. As the more time passes, your velocity, the rate at which your velocity changes increases. Anna?
Yeah, so if you were just to flip that, if you were just flip it, it would be decreasing. instead
So
of
like this?
increasing. No, the one you were just on, up,
If you flip that one,
yeah. If you're just flip like the lines where it was going like, like opposite, would it just be decreasing?
so it looks like that?
Yeah.
Okay. Velocity is, all of these velocity is decreasing,
Mhm.
because as you go from left to right, you're going down on the vertical.
Right.
Here, you're decreasing your speed slowly at
Slower
first.
and then faster.
Yeah, correct.
Okay. Even though it's pointing down, it's still going faster.
Oh, I apologize. It is going slower, the rate at which it's slowing down increases. So you see there's a red light in front of you, you start applying your foot on the brake very gently to start with, but as you get closer and closer, you start slamming that brake down a little bit more and more and more, so that the rate at which you are slowing down increases.
Okay.
And here, you hit the brakes really hard to start with, because the car in front of you goes like they're about to stop, so you slam on your brakes, and then you suddenly realize that they're not stopping, and so you start taking your foot off the brake. Still
Right.
slowing down, not taking your foot off the brake. Well, actually, for the cars I've owned, I don't need the brake in order to slow down significantly. Lacey?
So for EUSA slowing down, like, slowing, or moving in the negative, slowly, and then for F, you would say moving in the negative, like, increasing the speed?
We're moving in the positive direction in all of these, because I'm above the axis in every single one of them.
Yeah, but for acceleration, it would be negative.
Acceleration is negative in these three cases.
Yeah, so would it be like negative acceleration for E would be negative slowing down, and then F would be negative speeding up?
So the language, when you say speeding up, slowing down, that's a reference to how fast you're going.
Or decreasing? And
So-
decreasing,
You are,
like decreasing?
you're slowing down with a decreasing acceleration. You're slowing down with an increasing acceleration. And then here you're just slowing down at a constant acceleration.
So, only when, well, possibly, what she said about, I don't think I'm right, but only when it's like, the position, that's when you're, and it's like these same scenarios from D to F, that's the only time that you're moving in the negative direction, even though you're above the T axis.
If this were position first time, then you would be moving in the negative direction.
Okay.
Because you start out at some, so if this was X first time, you're starting out some position far away from the origin, and then you're now closer to the origin.
Okay. So why would it be zero?
So why would it be what?
Why would it just be zero?
Why would, what just be zero?
Once you get like closer to the origin.
You're getting closer to a position of zero.
0 seconds, cause like you stop moving. Oh wait, no, because I just.
If it's position time and I hit zero, I hit the zero, that just means I'm passing the origin. I'm not necessarily stopping.
Oh, okay, I get it, thank you.
Okay. In fact, I guess, Amina, you started us off with this. Did I actually answer your question? Maybe? have to look back at what the question was.
So is displacement the same as position then? Cause that's what you asked.
Okay, so position versus displacement. Well, Lamina, before we get too far off again,
I think it's good.
okay. If you change your mind, you know where to find me.
That's it.
All right, so now Tanner's question, position versus displacement. So if I have, because in class the other day when I did the plus minus zero exercise, I had zero somewhere around here and my starting point here. So there are certain places where my origin, so I think I said to the right was positive. It's just a sad marker. So here, my displacement, assuming I started here, my displacement's negative, but my position's positive. So they're not identical. But if I move, let's say, 2 steps to your right, my displacement changed by 2 meters to the right, and my position changed by 2 meters to the right. So the change in the two are the same. So if I had a position versus time graph, and I started here, and I moved like that, my displacement time graph, if that's my starting point, displacement graph would look identical except for the fact that I would start here. Those lines should be parallel.
Okay.
So if that change right there is 3 meters, then that change right there is also 3 meters. It's just the difference between them is sort of your reference. Questions? Lydia?
If acceleration, this is like question number 5. If acceleration is 0, that means velocity is 0.
No.
Or does it mean?
If acceleration is 0, what does that tell you about velocity?
It's constant, or it's not moving.
Either one. Yep. Did you hear that? Okay. So that's why if acceleration is 0, then the total force is acting on an object is 0 and the velocity doesn't change. Those are all called equilibrium. So if acceleration is 0 and it's not moving, that's called static equilibrium. And if the acceleration is 0 and the object is moving, that's called dynamic equilibrium. And one of the reasons for sort of a rationale why it can be treated the same is right now, relative to me, you're not moving. But if I start walking towards you, you're now moving from my point of view. But that doesn't change anything about you. So I can legitimately say that you are moving from my point of view, but you're still in equilibrium because nothing else has changed about you. So how fast an object moves is always dependent upon some reference. And changing the reference should not change the sort of the physics of the situation. And that's why I could treat the entire universe where I am the origin. And I am. So you take, say, the middle of my left eye, it has not moved my entire life, but the universe around it has. And I should be able to work out the physics, all based upon that reference right there. Not necessarily the simplest way to do it, but changing reference frames, the physics should still work. All right, there were a couple of questions out there that I cut off. Brittany?
This was for 7E. So it was assuming, okay, this is the car's velocity goes from 24 meters per second to negative 20 meters per second at a constant acceleration
Okay.
in 10 seconds along a flat straight road. So for E it says assuming that t equals 0 going, 24 meters per second at the beginning of the 10-second interval. At what time did the car stop moving? So I did like a table.
Okay.
Showed us an example, but I got in between like 5 and 6. Oh, I don't know if I'm supposed to say that, but, I got in between two numbers and I was just plugging it in, trying to figure out which number it was, and I did like half, quarter, and all this stuff, and I couldn't figure out exactly what that time was.
Okay.
Is there a way for me to figure that out?
Yes.
Okay.
All right, so let me, I'll set up a similar problem. I don't remember the exact numbers used, but it went from a positive to a negative, and I gave you time. So initial velocity, we'll just say 30 meters per second. Final velocity is, we'll say negative 10 meters per second. And the time is, I want to make sure it doesn't come out nicely. Five would do it. We'll just say 7 seconds. Yeah, that won't work out nicely. Okay. So you set up the chart. So time, velocity. I did not tell you acceleration. So when you set up the chart, do you just?
I did, go ahead and figure out what the acceleration
All right.
was.
So acceleration is change in velocity over time, which is negative 10 minus 30 divided by 7, which is negative 40/7. That is just horrible. I might change that. Nah, let's go with it. Shouldn't have picked sevenths. So time in seconds, velocity in meters per second. So at 0, I'm going 30. After 1 second, my velocity changes by negative 40 meters per second each second. So that's negative